So when we talk laws of exponents, we do have to talk about 5 different rules. The 2 that people tend to get confused are the top 2 that you see there. The difference between them. This is the law of exponents for multiplication, where this one, they tend to call this power of a power. That's a fancy term for saying something with an exponent that you're raising to another exponent. So just keep in mind the difference between the 2 of those. If you don't see the difference in the laws right there, I'll just kind of point them out to you. This one, when you're multiplying, has 2 bases that are the same. So you keep that base over here and add your exponents. The difference with the one next to it is that you have 1 base with 2 powers on it. That's when you keep the base and multiply the exponents. So that's what you see in the second one. The third rule tells us the rule for division, which is keep the base, subtract the exponents. The fourth rule in the bottom right over here is the rule for negative exponents. This is kind of the simplified version of it that we're kind of used to seeing. The rule for negative exponents, you'll always say put it under 1. That's kind of the rule. If it's already a fraction, you're going to flip the fraction and use the exponent for both of them. So we'll kind of talk about that today. And then all of our favorite rules, the easiest one, anything to the 0 power is 1, always. So what I would like for you to do for just a couple minutes here is to take a look at questions 1 through 6. See what you can do without a calculator. So just see what kind of answers you get by hand, see what the people next to you get, compare your answers with them. So we're going to take about 5 minutes to look at those, and then we'll talk all together about them. So as you check a few of these, I've put up answers on the board to the first 5. I did not put up 6 on purpose because that one's always an interesting one. A lot of times we try to just force our way through dealing with some of the exponent rules on number 6, and there's a trick to that one that will make things easier for you. Couple things that I see typically with laws of exponents. First off, no need in something like question 1 to actually multiply out -1 12 times. 1 times itself, any number of times, is 1. And if it's negative to an even exponent, it's always going to be what kind of answer? Positive or negative? Positive, right? So a negative number to an odd exponent will always turn out negative. A negative to an even exponent will always turn out positive. Now, question 2, no one usually wants to ask about that one because it's like the second one and looks super easy. But there is a difference between what you've been given there and this. What is the difference between those 2? The one that I've written on the right in parentheses is actually saying take -3 and multiply it by itself 4 times. What is the given problem telling us to do? Essentially, yeah, what you're saying is right on that one. Essentially, it's like this. It's really saying multiply 3 by itself 4 times and then make your answer negative 1 time. Okay, so the negative is not in the parentheses. Therefore, you have to take the negative at the end on number 2. Okay, so just keep in mind the difference between the 2. If there's no parentheses, the only place you can assume parentheses is around the base itself, not including the negative. Okay? I've seen a lot of work on different ones for number 3, but this is a good example of what I was talking about with the negative exponent rules. The negative exponent rules, you always say put it under 1. Well, if you put that entire fraction under 1, you're going to make your life harder. So in this case, if it's already a fraction, the negative exponent rules can just say flip the fraction upside down and lose the negative in the exponent. Then you're just taking 3 to the 3rd power, which gives you 27, 2 to the 3rd power, which gives you 8. Easy enough? 4 and 5, usually not a super difficult type of question. 6, you can make it through 6 with what I like to call brute forcing your way through the math. So I've seen some people say, okay, I know 16 squared is 256. I'm going to move that 64 to the bottom. I'm going to multiply those out by hand because I don't have a calculator and go for that. Another way to do this is what we call common bases. If you reduce the bases to smaller numbers that are all the same, you can make it through it a whole lot easier. So for example, if I look at 8, 64, and 16, I can rewrite all three of those as a smaller number to an exponent. And it needs to be the same number. So just think for a moment. Can I use base 4 for all of those? No. Which one tells me I can't use base 4? 8, right? 8 cannot be written as 4 to a power. That usually tricks us because we like to think it works that way, but it's 8 times, or 4 times 2 that gives me 8. So what base could I use for all three? 2. All right, so here's what we're going to do, just to show you the setup. I am removing each of the bases, and in each of the bases place, we're going to write them as 2 to a certain exponent. So that's the same setup. I'm just replacing the bases. So 8. 8 is 2 to what power? 2 to the third. That's a good replacement for 8. I haven't actually changed anything, right? Just wrote it as an exponent. 64 is 2 to the what power? We might have to think about that one. 2 to the... I know someone has it. I think I heard it. 5. 2 to the... So 2 to the third is 8. Next up is 16, then 32, then 64. So that's 2 to the 6. There you go. 16 is 2 to the what? Fourth, right? 16 is 2 to the fourth power. So once you've written them all as base 2, then you can use exponent rules on all of these to simplify. All three of these have that power of a power rule right here. Power of a power rule says I do what with my 2 exponents in each of those 3 green circles? Multiply. So that becomes 2 to the 9th, 2 to the negative 6th, 2 to the 8th. You can go a couple different directions from here. Some people, as soon as they see the negative exponents, drop those to the bottom. That's fine if you want to do that. It doesn't matter either way. I like to simplify on the top of the fraction and on the bottom and then go from there. So that's my preference. So if I did that on the top, this is the multiplication rule, which says keep the base and do what with my exponents? Add them. Now I'm in a division situation. Our division rule says keep the base, do what with your exponents? Subtract. So if I do that, I get 2 to the negative 5th. Now what's my negative rule tell me? Negative exponents, they go where? Under 1. Last but not least, 2 to the 5th power is what number? 32. That is as difficult of an exponent problem as I would give you. But from a math teacher perspective, the upside of that problem right there is in one problem, I made you use every exponent rule except to the 0 power. I could make that work too if I wanted to. But yes, sir.
Well, what the 2 2s? What if they're not both 2 with the same base?
If they're not the same base, then you are stuck. So if I'm going to give you something with that much work, you're going to be able to get to the same base.
Okay.
That's a good question. Okay. Any questions on basics here? That's what we like to consider the basics. All right, so let's take a look at a couple laws of exponents using variables. Try what you can at your desks. 7, 8, and then what after that? Let's go 7, 8, 9. We'll just go those 3. All right, I put a couple answers up for you for 7, 8, and 9. Usually 7's pretty straightforward. 8, you need to treat it in like multiple parts. I consider the numbers by themselves first and just reduce that. Those both divide by 9, so 3 over 5. Then I consider each set of letters one set at a time. It may be a different way to think, but I almost, for this one, use like the division rule, but kind of flipped upside down. If I subtracted 4 minus 3, it gives me the 1, but on the bottom. So I don't deal with the negative exponent. You can use that if you want. Really, honestly, if I'm thinking about the A's there, my mental thing here, and I would never write this out, but I'm kind of thinking that's 3 A's on top, 4 A's on bottom. That just leaves me 1 A on bottom, right? I'm never going to write that out, but I'm thinking that rather than subtracting, oh, I have a negative exponent, let's put that on the bottom. That's too many steps. This is, better for me to think of it that way. Same type of thing for the C, only you can subtract your exponents on that one pretty easily and get a positive C to the third, so that stays on top. The biggest issue with question 9 is typically we forget that the negative 3 also gets to the third power. So negative 3 times negative 3 times negative 3 does give me that negative 27. And remember that when the exponent is on the outside, it's essentially like distributing. So if you need to distribute that exponent and write it out as negative 3 to the third, x to the third, y to the sixth, think about it that way. Okay? Let's talk question 10 real quick. Which exponent rule is going to apply to question 10? Or what operation are we doing in question 10? Okay, we're going to be adding the exponents because we're multiplying right there. So it follows the multiplication rule. If I'm multiplying things with the same base, the rule is keep the base, add the exponents, whether it looks weird or not. Okay, so you're just simply adding together those two exponents. What's going to happen when I do that? The 3's are going to cancel out, and I'm just going to get a to the 2x. Yep, good. Any issues with that? All right, let's finish up with a few of these. We're not going to go the whole way through, and then we'll talk rational exponents very briefly. There's a number of ways to approach number 11. Are we all of the type of people that we immediately move the negative exponents? Or do we do that last? Usually it's one or another in the class. I don't move them first. I usually deal with everything else and deal with negative exponents last. So when I am doing something like question 11, I'm looking at the x's and saying, okay, my division rule is keep the base, subtract the exponents. What's negative 2 minus negative 3? 1. Then I'm going to do the same thing for the y's. Keep the base, subtract my exponents. 3 minus 2 is also 1. Don't have to write that. Nothing to combine my z with, but it does have a negative exponent, so where is it going to go? On the bottom. Sometimes dealing with the negative exponents last helps you avoid doing too much negative exponent work. But, again, that's totally up to you. All right, 12 is kind of a tricky-ish one. What are we doing in this problem? Or what should we be doing with this, the 3y to the negative third? Distributing. Now, think about, and we always just say it's distributing, but what math operation is that? It's multiplication, right? So if you need to think about this as 3 different multiplication problems, do it like this. Now, if you don't need to write this out to use the correct exponent rules, don't. But if you do, that's totally okay. What you are doing is a multiplication on each one of these. So you're multiplying the numbers. So let's take it one term at a time. Right here, that first distribution, I'm multiplying my numbers. I can't really combine my x's and my y's, different variables, but they both have negative exponents. So where are they going to go? On the bottom of this particular term. This is not like one big fraction, right? So I'm going to just handle one term at a time. There's the first one. Let's look at the second one. I don't have anything to multiply that 3 by. But I can combine my y's. Y to the negative third and y to the first is going to give me what? Y to the negative 2. So I can either write that, or in the same step, what can I do? Take that and put it where? On the bottom of its term. Third one. Don't have anything to multiply the 3 by, but I can combine my y's. Negative y to the negative third and y to the second gives me y to the what? Negative 1. So therefore, it's going to go where? On the bottom. If you wanted to get a common denominator to put all 3 of those together, be my guest, but I'm not asking you to do that. So don't do too much extra work, honestly. Okay. That's about as far as into exponents as we're going to go. 13, 14, and so on. We're not really going to worry about those. So we will finish up today with a little bit of rational exponent work. All exponents in one day. Lovely, I know. So rational exponents, if you don't remember these are the root exponents. Or they're fraction exponents that turn into roots, I should say. Okay? So I would actually, in this box, like for you to cross out this. I want us to focus on turning it into that form, and I'll show you why in a minute. And that will be a little bit different than Algebra 2 because I think they do work more with that first version, but I have reasons for not. So what a rational exponent is just a fraction exponent, but all fraction exponents indicate roots. So what this rule tells us is that the denominator tells us what kind of root it is, and the numerator becomes the exponent on the outside. That's basically in English what it says. So using that type of rule, in question 1, if we have something raised to the 1/2 power, what root is it telling us it converts into? A square root, right? Do you really have to raise something to the first power from the top? No. So don't worry about that. So we use these because we don't think in fraction exponents. I don't look at 100 to the 1/2 power and know how to evaluate that in my head. If I can translate that into a root in my head, those make sense. The square root of 100 is just 10, right? Now, rational exponents, just because they're fractions, it doesn't mean that they don't follow exponent rules. So in a question like number 2, this is still a power of a power. So think back to the last page. What do we do in this situation with these kind of exponents? We multiply them. Now, every year someone says, can I just do the square root of 16 raised to the 3rd power and then do the square root of that? Yes. If that's faster for you than multiplying the exponents, be my guest. Now, here is a great example of why I crossed out that middle thing. So, did you have a question, Jake?
1/2 16 as well, or you did 16 there?
Do you do 1/2 of 16?
You're like, do you multiply 16 by 1/2?
No. So the rule is keep the base,
Okay.
multiply the exponents. Yes. Good. All right, so now let's convert this to a root. So using our rule, let me just play devil's advocate for a minute and say we didn't cross out that middle one. You don't have a calculator. This middle rule right here said that you can write this as the 4th root of 16 raised to the 3rd power. What would you have to do first in that situation? 16 to the 3rd. Anyone know that off the top of their head? I know 16 squared is 256. I mean, I don't know what it is. Could I figure it out? Yes, not in my head. It would take me a minute. So I'd have to get a really big number, 256 times 16, and then figure out what's the 4th root of that. I'm not real good at that either, okay? So the reasoning for not writing it like that is because of what happened right there. Now, let's say I write it this way, the way that I prefer. If I write this as the 4th root of 16 raised to the 3rd power, What am I doing first in this situation? The fourth root of 16, do we know what that is? 2. Do we know what 2 to the third power is? 8. If you keep that exponent on the outside rather than the inside, you are avoiding super big numbers. Okay, I'm trying to help you be able to do these things without a calculator. I'm not trying to force you to do massive numbers in your head. Okay, there's always a way around it. Now, 3, 4, 5, and 6, all very similar questions. And they are all there to help us tell the difference between where the negative is. If you notice, the negative is moving to all different places. 3 is similar to the one question we did on the previous page. Okay, so tell me, if there's no parentheses there, how am I going to write this in root form? Where's the negative going to go? I can only assume parentheses right here. That's all I can assume if they're not written. Therefore, when I rewrite this, what kind of root are we looking at? Cube root of 27 raised to the second power. Where does the negative go? Outside. Now, we don't really need practice with actually working through that root and that exponent. That's not the point of this. The point of these 4 problems is where does the negative go? Okay? So in this case, I would do the cube root of 27, which is 3, raise it to the second power, which is 9, and then make my answer negative. What's the difference between that question and number 4? It's the negative inside. Now, can I take a cube root of a negative? There's always an argument about this one. You can take odd roots of negatives. You cannot take even roots, or you can, but they involve i's. Right? We're not there yet. We'll get there. An odd root of a negative has an answer. What is the cube root of negative 27? Negative 3. Because negative 3 times itself 3 times gives me negative 27. Okay, so that, where the negative is on that question changed the answer. 9 versus negative 9. Now, where's my negative on number 5? In the exponent, right? If it's in the exponent, what do our negative rules about exponents tell us? Where does it go? On the bottom of a fraction. So when I write this, I'm going to do 2 different things. I'm going to put it under 1, then do the cube root of 27 raised to the second power. We already know what that is, so we can quickly say the answer to that is 1/9. And then last but not least, in 6, we have 2 negatives, both in the exponent. The exponent one tells us that, again, the root is going to go on the bottom. The negative in with the 27 stays there. So when I would rewrite 27, or number 6 here, sorry, it would look like that. Now, does that change your answer in this case? No, because the negative, once you square it, becomes positive again. All right, we're going to do only about 2 or 3 more questions, and we are done. Okay? Get a little bit of homework time. Would we prefer that? One class told me it was hot, and I was like, really? You prefer to stay inside with masks? Okay, cool. I prefer outside too, so we'll go. If we can do it, we're going to do it. All right, so now the rational exponents, to finish those up, they can go both ways. So what we saw in 1 through 6 is fraction exponents that we turned into roots. Roots make more sense when it comes to just plain old numbers. We know how to work with those with numbers. When you throw variables into the mix, those don't make as much sense. So sometimes you're going to go from root form back into exponent form to help yourself figure it out. Now, this will be weird to some of you on question 7, but it will work. Remember what I just said? I said roots work better for numbers, where exponents work better for variables. So I'm going to take this all back to exponent form for 1 minute, and then we're going to deal with it in 2 separate pieces. So first off, use the definition above. If I took all of this and took it back into exponent form, we're talking rational exponents, right? So the type of the root, the 6, where does that go on my exponent? Top or bottom? Go back up and look. The type of the root went on the bottom. The exponent on the outside went where? On the top. Before I do anything, what happens to that exponent? 2 over 6 reduces. Okay, don't ever leave it in unreduced form. Now, think exponent rules. When you have an exponent on the outside of the parentheses, it essentially distributes to everything inside. So I'm going to distribute it to the 8, to the A, and to the B. This is going to give me 8 to the 1/3, A to the negative 1/3, and B to the 2/3. Any issues so far with that? All right, so here's where I split it mentally. Do you know what 8 to the 1/3 is? We don't do numbers in fraction exponents. We do numbers in what form? The root form, right? So here I'm going to split it, and I'm just going to take this back to root form. 8 to the 1/3 is the same as what kind of root? The cube root of 8. Is that something we can find? Yes, it is. What is the cube root of 8? 2. So now that I've simplified that, I can deal with the rest of it as exponents. So here, all we have to do to simplify that, the only thing we really have a problem with is the A to the negative 1/3. If it has a negative exponent, where does it go? On the bottom. So my final answer is actually going to look like this. Okay, you can leave variables with those kind of exponents, but it's sometimes good to take the numbers back into root form. They make more sense. Okay. I think I have like 2 more questions. 8. Let's take all of these back into exponent form. Okay, we don't know how to multiply different roots of x, but we do know how to multiply x's with exponents. So the first one, this is a square root. How can I write that as an exponent? 1/2. The cube root is written as 1/3. The 6th root is written as 1/6. This is a multiplication problem. According to our laws of exponents, multiplication says I do what with the common base? Keep it, and do what with my exponents? Add them. This is the only downside to this because we don't like fractions. In order to add those fractions, what do I have to do? Common denominator. If you need to go out to the side and deal with just the fractions, that's totally fine. What is the common denominator? 6. So that is going to become 3 over 6 instead of 1/2. 2 over 6 instead of 1/3. Keep the 1 over 6. If I add those all up with the common denominator, what do I get? 1. What looks like a horrible problem ends up super nice. Do you have to write the 1 exponent? No. All right. I think one more question on the back, then I'll tell you what your homework is because I do skip around for your homework this time. No more questions on the back, I don't think. I'm done. No, one more. 10. 10. Oh, actually not 10. 11 and 12, solving. That's what we did this for. I forgot what I was doing. All right, so solving with rational exponents is not super difficult. There's 2 ways of doing this. Anyone have a gut idea as to how you want to do 11? Okay, so that's how, I always have to ask that because some people go back to roots and solve it that way, and some people do the exponent way. So y'all have been taught to get rid of the 3 over 2 exponent there. You do it 2/3 exponent on the outside, but if you do it to one side, you also have to do it to the other. Okay, all you need to do then to get your answer, now you're going to take the answer over there, the 64 to the 2/3, switch that into root form to figure it out. What kind of root's that going to be? Cube root of 64 raised to the second power. Remember, put that power on the outside again because you don't want to do 64 squared and then find the cube root of that. So first, we're going to find the cube root of 64, which is what? 4. Raised to the second power means my final answer is 16. Last but not least, question 12. Very similar. What exponent are we going to use to get rid of the 2/3? 3/2. So just take that to the other side. So this gives me x minus 1 is equal to, let's switch this into a root. What kind of root is this going to be? Square root of 25 raised to the 3rd. Now this one has one different thing in it that we have to remember. When we are simplifying on the right-hand side and I take the square root of 25, when we are solving for x, what is the answer to the square root of 25? Not just 5. Plus or minus. Now, why did I not do that on the previous question? It's a cube root. Cubes, odd roots, you do not do plus or minus. Even roots, you do. So that means I have two answers to this. I can keep going with the plus or minus as long as it applies, which means if I cube that, I can keep it as plus or minus 125. Now I do need to split it up. To get my two answers, I'm going to do 125 plus 1 and negative 125 plus 1. So remember, even roots have the plus or minus, odd roots do not. All right? All right, so before we go out to do some homework time outside, I'm going to read off to you because I forget what I put on here for homework. Today I skipped around a lot on homework. So, what you will see for homework is that I very much try not to assign questions that we haven't discussed something similar to. So you're going to see kind of like a lineup here of we covered these questions and stopped at a certain point in the notes, and therefore those types of questions will not be in your homework, because I haven't gone over that. So, laws of exponents on page 17 and 18. We are going to do the odd questions from 1 to 21, but just the odds. But I stop at 21 on purpose because I did not do those last couple questions when it came to the laws of exponents. So I cut it off the same place there as the notes. The rational exponents, you are going to do 1 through 11, not odds, 1 through 11, and 21 through 24. So again, kind of skipped there to the solving part. So 1 through 11 all, 21 through 24 all. Does that make sense? Okay.